So looking ahead, again, past this next block day, we got 4 weeks until the next break. So, a whole month straight of school. How terrible is that? 2 units in between there. This one's on solving. Again, today is with a calculator. Graphically, that basically means with calculator. We've got provided notes, so we'll start filling those in. Again, this is an easy day, but you just have to make sure you know how to put it in the calculator, where all the buttons are. The calculator does all the work. You just have to, make sure you know how to communicate with your calculator so that you can tell it to do what you want it to do. Yes, for AP Calculus, it is super important that you know how to use your calculator effectively. So this will help get you more used to the calculator than hopefully you already are. All equations can be solved with which of the following techniques? Well, not everything factors. Completing the square, no, that's a pretty specific method that doesn't work all the time. Algebra techniques, like if we give you a no calculator test, then everything better work with algebra. But this says all equations, well, they can all be solved with graphing. So there's going to be some crazy equations today, but that's fine because your calculator is going to do all the work. Okay, so grab a calculator and let's walk through some things together to make sure we're good here. Make sure your calculator is in. You want to guess what what goes in that blank? Radian. Make sure your calculator is in radian mode. Unless the problem specifies degrees, but the problem is almost never going to specify degrees in math. I would say this is where you need to be careful, because when you're in physics, I feel like physics you're usually in degrees, math you're usually in radians. So be careful. Most of you looking around are using your own calculator, or at least a bunch of you are. And so be careful going back and forth between physics class and math class on what mode you're in. B, use algebra to get 0 on one side of your equation and then that side into y1 and 0 into y2, although we'll do this a different way in a moment. There's a couple ways to do this. Or do not shift anything, like in the equation. Simply put the left side of the equation into y1 and the right side of the equation into y2. If you do this, you will likely have to play with your window. Therefore, don't use this method. I would say use method number 1. Get 0 on one side of the equation. That's preferred. And the reason it's preferred is if you're trying to find where your equation is equal to 0, then you're looking for where it crosses the x-axis. You always know where the x-axis is. The second method is you're looking for where the two equations are equal to each other, so y1 and y2, but you don't know where they intersect. So you have to play with your window to figure out, well, is it way up here, is it way down there? Every time you got to go looking around. So it's much better, and it doesn't take much algebra to get 0 on one side, because you're just adding things or subtracting things, and it just makes it a lot easier. So I will almost always do it that way rather than 2 equations. All right, part C, set your window. The directions will tell you what to use for the x-min and x-max. Like it won't say x-min and x-max. It will say something like find solutions on 0 to 2 pi. Something like that. So that would be your hint to you only need to look from 0 to 2 pi. So x min is 0, x max is 2 pi. So we'll tell you, we'll just use some coded language in there. We won't come right out and say x min and x max. For the x scale, that's basically how often you want a tick mark in x. It's kind of up to you. It really doesn't matter. But a lot of times we'll use pi over 2 or pi over 4. That'll put hash marks at regular spots. Again, it doesn't really matter what you pick. It so much doesn't matter that I'm going to even put doesn't matter. So not a big deal on that one. For y min and y max, just make sure to include 0 if you set one side equal to 0, which is how we're going to do it. So you're looking for where it's 0 rather than looking for where the two equations intersect. If you entered one side into y, the other side into y2, without setting it equal to 0, you usually have to play with your y min and y max to see where the two equations intersect. Which is why we don't do this method, because it's a lot easier to move something over in the equation than to play with your window to figure out where the two things intersect. And then you can always change the window if you need to see something, sort of like zoom in on a piece to see what's going on there. Part D, stating the answer. There are an infinite number of solutions to trig equations. Right, we sort of talked about this when we talked about inverses. Inverses give you one answer, but equations have multiple answers. Right, if sine of x equals 1/2, well, that's pi over 6 and 5 pi over 6, but it's also negative 7 pi over 6 and negative 11 pi over 6 and all the other combinations of things. So this is where things are going to get tricky, because your calculator, obviously you're not going to use your calculator to get an infinite number. You're going to have to know a little more than your calculator knows. Most of the time, directions will tell you to find, you can keep that one, but that's what we're looking for now. The directions will tell you to find all solutions from 0 to 2 pi, because that's, one trip around. So usually that's what we're looking for. The solutions to the equations will be the x-coordinate, or the x values, the intersections. I'm going to change this up from my notes here, so use the 0 key. This is how I'm going to say to do it. Found by pressing, let's see, second calc, and then the number 2. So if you got a calculator, you don't really even need anything in to define this. Second calc, or second trace, and then the second option is 0. So you'd be looking for where the zeros are. Round all answers to 3 decimal places, 3 places after the decimal point, unless told otherwise. The reason is on the AP test, So next year on the AP test, it's 3 decimal places. So we try to just get used to that now. So 3 decimal places. If you need to do something with your answers, so this is a little more for later, but this becomes really helpful in calculus. Use the stow button. Stow is short for store, meaning like keep, as opposed to like the grocery store, not that kind of store. So it means like keep this value in mind, and that button is when you're on the home screen. We'll play with this more later. To get to the home screen from the graph screen, you press second quit. That takes you back to the main screen. Then you press the stow button. And the stow button comes with an arrow. Press the stow button. Let me just get an answer on there. So let's say we do something really weird and we get some crazy answer that we want to use later, but I don't want to write down 13.03462322. I want to use that later. And especially in calculus, sometimes we need to use that value several times. So you go to stow, and that just means save that as, and then you can call it whatever you want, A. And then anytime you hit alpha A, you've got 13.03 whatever. So rather than having to, memorize or write down 8 decimal points, it's nice to write stow, and then the calculator is remembering everything for you. Stow it into A or B or C or whatever. If you really got complicated, you might have to use several values. I feel like even in calculus, we never, shouldn't say never, I don't know that we've ever used more than one stored variable. So. All right, typing powers of trig into the calculator. This gets a little bit weird because cosine squared of 7x. What is being squared there? The cosine, the 7, the x, all of it? The cosine. But you can't type it into the calculator like this. So you need to write cosine of 7x and then squared. So that power needs to make sure you're squaring or cubing or fourthing the right thing. How about that next one? What's getting the fourth? Well, the tangent is, but not the 3. So be careful. We don't want to fourth the 3. We do want to fourth the tangent of 5x squared. Secant. We've talked about this before. We don't have a secant button on the calculator. So it's 1 over cosine. So you could type this in as, you could use the fraction thing, or you could do just 1 divided by cosine of x. Or if you like to see the fraction, you can do the fraction. And then number 4 sort of combines the issues with a squared and a reciprocal. So 1 over cosine of 4x squared. Again, today is more about the calculator than anything. All right, number 1. So grab your calculator. Consider that equation. 3 cosine squared equals sine of 2x. Like, I can't do that with algebra. Yeah, there's something squared, there's a 2x in there, that's going to be crazy. So instead, let's move things over. Which side you move it over to doesn't really matter. So I'm going to move the sign of 2x over. And now I've got y1. So let's type that in and see what it looks like. Oh, there's a squared there, so cosine of x. Careful with the parentheses. You may realize this. Sometimes if you mess up the parentheses really bad, the calculator might tell you you have mismatched parentheses, something like that. But if you only mess them up a little bit, it might try to fix it for you, and then you're not sure if you got it right or not. So 3 cosine of x squared minus sine of 2x. It tells me that I want the solutions from 0 to 2 pi, or sketch the graph from 0 to 2 pi. So that's the not so veiled hint as to what x min and x max should be. 0 to 2 pi. So window 0 to 2 pi. Once you press enter, this is a little bit weird, maybe, or scroll off of x max, it doesn't say 2 pi anymore. It says 6.28. But hopefully you remember that pi is 3.14, so 2 pi is 6.28. So it's not wrong, it's just putting a decimal in there. X scale, again, that doesn't really matter, but I guess we can go pi over 2. I really don't know how big to make y min and y max. Cosine and sine usually have a max of 1. So there's 3 of them, there's 1 of them, so I don't think this thing should get more than 4 or negative 4. So I'm going to go negative 5 to 5 and see what happens. But I can always come back and change that. If it doesn't look good or I need to see more or less, it's an easy fix. Uh-oh. I didn't mean to do this, but I'm glad I did this. And I've done this enough times wrong, there's something wrong about that I recognize what's happening here. Do you know why that graph looks so flat? Because if I only went to 6 degrees, that's not a lot of change, 0 to 6 degrees. So I'm guessing I'm in degrees. I'm supposed to be in radians. If you get a flat graph, it's probably, or a relatively flat graph, it's probably because you're in degrees. Because you said go to 0 to 6, but 0 to 6 degrees isn't very much. Let's see if this looks better. There we go. Sketch the graph here. Okay, so it goes down, up, something like that. It says sketch, so I'm not getting too crazy here with my accuracy. The main thing I want to see is all these places where it equals 0. In fact, the first question there is, how many values of x satisfy the equation? Well, 1, 2, 3, 4. List the solutions. Okay, here comes the fun part. So do you remember where we find the x-intercepts, or the zeros? Where that option is? I mean, I can see them, but how do I get the calculator to find what they are? So you could look at the table, but the table's probably not going to have, I mean, there's one close to 1, I guess, but it doesn't have any that are exactly 0. So table's not a bad thing, it just doesn't help me as much as I'd like right there. So go to Second Calc. Second Calc. Second Calc, and then go to 0, because you want to find where the graph is equal to 0. And then that's all you have to remember, because the calculator will walk you through the next steps. Left bound means get to the left of the 0. Like your calculator is basically going to guess and check to find the answer. So the left bound is, where do you want me to start guessing? So get to the left of the 0 and press enter. And then it asks for the right bound. So we get to the right of the 0 and press enter. And it's making these little arrows up here. That's saying the calculator is going to guess in that little window. Now it asks for a guess, like where to start. It doesn't matter. If you get closer, it saves your calculator like milliseconds of time. So it doesn't matter where you put it. It can find it pretty quick. So there's my first 0. 0.983. X equals 0.983. Right, there's 4 of them, so I'm going to walk you through one more of them together, and then I'll let you find the next 2. So second calc, 0, left bound, so get to the left of the next 0. By the way, if you can't tell if you're left or right of it, you can use the sign of the y value to know if you're above or below. Maybe that's helpful. Left bound, right bound means gets to the right of it, and then guess, you can just press enter, make your calculator work a little bit harder. 1.571. I think that's pi over 2, but it doesn't matter. 1.571. All right, I'm going to press pause. You see if you can find the other 2. 4.124 and 4.717. I saw that on a lot of pages out there. Number 2. Consider this equation. And again, the 2 ways to work this are, you can set one side to y1 and the other side to y2, and then you have to look for where they intersect. But it's just a whole lot easier if you move something over. So I'm going to subtract 3 cosine x and add 1 and find where that's equal to 0. How many solutions are there from 0 to 2 pi? I have no idea until I look. Okay, I've got some cube things going on in here. Take the time to double check your equation, because your calculator is not going to make a mistake. The only mistake is going to be if you type something in wrong, put parentheses in the wrong spot, hit sine instead of cosine, negative instead of positive. All right, I feel good about that graph. If you want a good window, do you know what a good window, a y window might be? So we're going 0 to 2 pi, but the y window, like sines and cosines are always between -1 and 1. So the most this could possibly be is 2 plus 3 plus 1 is 6. So if you're worried about your y window, that's one way to do it, is to look at the coefficients. If you're not worried about it, then you can just leave it -2 to 2. I'm not going to see everything, but I don't really need to see everything. All I care about is where does it cross the x-axis. Okay, that's a weird one. So how many solutions are there from 0 to 2 pi? I think I would say 4. You do have to be careful on things like this, because sometimes you can't tell if it's 1 or 2 and you got to zoom in, but that's pretty clearly 2. So 4 solutions. Now I don't have to find all of them. It just says find the sum of the 2 smallest solutions. So that's a little bit of a time saver. Second calc 0. I guess here's the downfall of not seeing the whole graph, is that sometimes you can't find your cursor. But there it is. Left bound means to the left of the 0. Right bound to the right of the 0, and then guess. .3331 ... Now, I'm going to use that later, so I don't want to write down all of those decimals. Gentlemen, this is where I want to use the store feature. So, with that still on the screen, don't do anything other than second quit. Second quit. And then, because that's the last thing you did, that's sort of the last thing in the calculator's brain. So press store, and I'm going to call it A, and there it is. In fact, I'm going to label it A so I know what I did with it. So A is the .3331 ... Alright, let's go back to the graph and do the same thing for that second one. Second calc 0. Left bound, right bound, guess. So my second solution is .4797 ... But I don't want to remember that or write it all down. So second quit, and then the store button. I'm going to call this one B. And then A plus B. All I have to do now is tell my calculator to do A plus B. A plus B. .813. Questions on that one? We're not going to do the third one. I just want to talk about it briefly. How many values satisfy the equation? I don't know. You'd have to graph it and see. It turns out there's 4. Find the product of the values that satisfy the equation. So you'd have to find A and B and C and D and multiply them all together. And it's in the multiplying that we find out if you rounded or if you use the store button. Because if you round early and then multiply, you're probably going to lose something. So this is why we say don't round till the end. Use the stow button, and then just do A times B times C times D. It's just a lot of typing to punch that all in. So we'll leave it at that and be done today. So it's easy today, but you got to know how to work your calculator and how to make your calculator do what you want it to do.